Okay. Hey, everybody. My name is Jacob. And I want to tell you a little bit about why I think shift left sucks for software engineers. So who am I? Well, I never went to college. I've been working since I was 14. I've been a UPS driver. I've changed tires, worked in grocery stores. I've been in desktop support, network engineering, software engineering, much more exciting. Security engineering, maybe the most exciting. And when I left Snowflake, I managed 52 people in 3 global teams as part of the engineering executive leadership team and the security executive leadership team. And my team and I owned security for the Snowflake product, and we worked with my counterparts, the CISO and corporate security director, to own security for Snowflake. I didn't really grow up and plan any of that. I didn't write it. Those are just a series of things that happened to me. And the most recent thing is that I left Snowflake in April of this year. It was a great run, decided it was time to do something else. And what's important to me right now is, spending time with my family, ride bikes in the woods, and build cool stuff with my friends. So that's what I'm doing. Before Snowflake, I was at a company called Collective Health. And prior to that, I worked for 10 years on the NetScaler load balancer, which was also pretty cool. So if you're a startup or a small business where scale is not your biggest problem, this talk might not be very relevant for you. And a lot of the stuff I'm going to talk about might be somewhat exotic. I think probably something for everybody to learn, but I'm just going to go ahead and say it's pretty far to the right because it's definitely not shifted left. And it may be totally fine to have a security engineer driven or even a deeply developer driven practice and get great results. So you can ignore everything in here and probably still succeed. I just want to make that clear. But my experience was that as you get closer to supporting 500, 1,000, over 1,000 software engineers, this idea that, well, one, you have to scale and that you should scale sublinearly becomes really important. And how you do that is, a varied and exciting game. So if your team is thinking you need to scale now and you think there might be more scaling in your future, then this talk is for you. And so my view is that shift left has failed to create a developer-led security revolution. I feel like I know that because we tried really, really hard, my team and I, to make that happen. And what we learned along the way informed our view and my view on where the future might be. So those conclusions probably could use some supporting arguments. And so let's start with an oversimplified worldview. According to Fortinet, shift left means conducting application security testing sooner. I think this is a fairly obvious and simple statement in 2024. But maybe what is much less obvious and way more complicated is how do you do that? How do you do that at scale? Probably 8 out of 10 AppSec programs have been launched using this diagram. We've probably seen it from the IBM System Science Institute. It says it's more costly to fix bugs, 100 times more costly, as a matter of fact. It gives a relative, but that institute doesn't exist. There's no data to back up the claims in this chart. It's an internal employee training. It's just like a made-up thought exercise. So it's not really the worst thing in the world, but the way it's been used and the way that security is traditionally thought about it just reminds me of this legacy security worldview that doesn't fully comprehend what software engineering is and often is not software engineering. But you can't really test the design right before it's implemented. So that's got to mean that there's more to shifting left than just testing sooner. It's probably going to be about baking security into every step of the development process and doing that contextually. And that means our good friends, software engineers, are going to have to get involved. They're going to have to get involved in learning archaic terminology they often struggle to find relevant. They're going to have to get involved in learning and doing threat modeling. Security engineers often struggle to patch and remediate on behalf of teams they're not on and for systems they don't own. So developers got to get involved. We call it DevSecOps. And it's an industry of, that takes findings that used to get delivered to security teams and then delivers them directly to the developers, and sometimes without any useful context. And these tools are not helping developers threat model or do secure design, just some more work that we found for them to be doing. So DevSecOps, pretty cool. Now, if you think all that threat modeling and patching might seem like a lot for a software engineer to understand in addition to their regular full-time job of software engineering, don't be ridiculous. You're absolutely right. And from my view, shift left is really asking, and they're being asked right here to become security engineers too. And let's just talk a little bit more about how that happens. So I kind of mentioned this before, but one problem is these security tools that are out there in front of developers are taking them out of their existing workflow. They're taking them out of the IDE. They're taking them out of Git, wherever. There's some of these tools that claim to be developer friendly. They do some nice things like integrate at a pull request level, but they often include false positives, miscategorized severity. Jeevan, in one of the other tracks, talked about, vulns you're not going to patch. They often lack the basic information software engineers need to confidently apply the pull requests. And many of these teams don't have any tests around dependencies, and they're going to struggle to upgrade a dependency even if the pull request is complete. None of these tools are helping them with that. Often they've got to click links and go visit tools like outside of the PR to get the necessary information to merge. So another challenge besides the tooling is that the security engineering part of it, right? Threat modeling is not really deterministic. That is to say, the same input does not guarantee the same output. If you ask 10 software engineers or security engineers to threat model the same system, you're probably going to get 8 different threat models. The output is completely dependent on the expertise of the engineer doing it. That means it's an art and it's not a science, and it can have significant blind spots for inexperienced users. Now, the worst part of that is that we destroy all of that art, right? Whiteboards get erased, Confluence gets ignored, Google Docs get forgotten. Code and tests are the only things that live forever, and it's probably just the code. I think personally we should focus on being a little bit more alive and a little bit less dead every day. So, don't work on dead things. My experience is that this is too much already for software engineers at scale. And maybe my spicy take is I think security champions prove it. I think security champions are human crutches that we use to prop up a cumbersome process that average software engineers struggle to manage. So let's talk about some more work that we found. These security champions are volunteers in most cases. They're a dedicated point of contact for security on a given team, and they've got to manage and translate this unfamiliar security work. They often become the owners of these DevSecOps tools, maybe the only owner on the team. Good for them, lucky. They may even own security awareness training, possibly the most exciting thing anyone here ever does. They might be owning that for their teams. So, often security teams, that's a kind of cynical view, I'll own that. Security teams are finding the most generous software engineers and then saddling them with owning security on behalf of their teams in the form of education and enablement. And they need to do all this while they're also full-time software engineers. And they do this because individual software engineers struggle to understand how to be a security engineer, and they've become codependent on others to bridge that gap. Security champions are carrying the teams, and for me, it's not fair, and their existence creates incentives for the cognitive offloading to continue. Now, we tried to solve some of these problems, and like all good problem-solving exercises, we found more problems. So I'd like to tell you a little bit about what did and didn't work for us, and then a little bit about where the next opportunity might be. So security is not a volunteer problem. You may have picked that up from some previous slides. So we just didn't accept volunteers, and we openly stated, contrary to Facebook and others, what they were doing at the time is we were not going to hire security engineers and put them on these teams to embed. We came to an agreement with engineering leadership that it was going to be the senior software engineers who had the visibility into the projects, and we were going to have them on every team. We decided to call them security partners because we didn't want to say champion. The role was really tightly scoped so that they wouldn't end up owning security for the team, right? Like software engineers don't own writing code for each other, they peer review it. So it would be the same for security partners. They would peer review other security engineers' work. We thought one partner for every 7 software engineers is a good place to start. One security engineer for every 10 partners, another good place to start. And that partners and software engineers would really get the same training because they're just peer reviewing each other's work. So we didn't necessarily need special above and beyond training, which kind of defeated the purpose. So with that role limited, that meant, right, every software engineer was threat modeling. And what we then wanted was a set of inputs that software engineers could produce that yield the same threat modeling output consistently. And we kind of figured out, and probably most people know this, that like humans are pretty good at drawing pictures and telling stories. Software engineers are good at consistently, this is important, describing their system in design docs, and they're good at consistently drawing diagrams of those systems. And interestingly, maybe not interestingly, obviously, conversely, security engineers pay like a really huge tax to understand design docs and diagrams that somebody else wrote. It's not because they're bad people. I'm one of those people. Like, it's hard to read someone else's stuff and just get it. So to make this whole kind of process more appealing and less foreign, we define this to our software engineers as a test case generation problem. It was kind of like an emerging view in the industry at the time. We wanted to make it simple to generate test cases from the diagram. We wanted to optimize for taking something that software engineers were good at and producing something that they were less good at. In other words, take the diagram in and output the threats. To avoid kind of throwing anything in the garbage, we didn't like that. We put all of this in GitHub. We had a markdown template that guided them through a stride per element process, and we checked that into GitHub. They would write the threat and mitigation pair as gherkins. Gherkins is a natural language to describe test cases. You can call it like that. And what they would do is they would draw a data flow diagram in Draw.io, and they would link that in. They would then bring this to a peer review of other security partners and security engineers, and it would be accepted. So what this produced was a quasi-code markdown, checked in, peer-reviewed, and more like a test plan than some abstract security thing. And so from that, we had really strong guarantees about quality, but super, super low throughput. The toil factor here was really high. And so just something that I think was important for us to realize is that culture is scarce and it's finite and it's ephemeral, and it's never idle. You're either building it or eroding it with every activity you do. And so we were definitely seeing that we were eroding it with the toil in this particular process. So we wanted to lower taxes, right? We wanted to lower taxes a lot because that's what toil is, and we wanted to put risk assessment and threat modeling on rails. We wanted to automate it. We wanted to collect data about it. We partnered with our developer experience team. We proposed something called Developer Portal. We tried to be big brain. We didn't want to propose another security thing. We wanted to propose that there's a problem getting from prototype to production, and security is one part of that. We built that out using internal UI components. We later migrated that to Backstage, and we can get into a little bit about what we built inside of there. So most people are familiar with Go SDL style risk assessments, came out like 7 years ago. You ask 3 to 5 questions to understand what they're working on, what the tech stack is, and you might trigger 3 to 5 more questions. The whole point here is to contextualize what the person is doing and only tell them security things that are relevant to what they're doing. And if you can implement those requirements, your residual risk is low. But if you can't implement them or there's no requirements, then you need to threat model. You need to discover new requirements. And the point here is that anytime you do a threat model, you want to backpropagate that into the risk assessment so that you never do the threat model twice. Once you learn these requirements, you want to feed them back into the process. Right, people can only think about 3 to 5 things at a time. Don't show them a long list. But more importantly, every threat model was really important as a failure because you don't want to end up there. You really want the risk assessment to deflect that. And if you view it as a failure, that means you'll very carefully look each time and make sure that you don't repeat that failure. So now an important breakthrough in developer threat modeling was something called rapid threat model prototyping. And we did not invent this. It is a rules-based way to annotate a data flow diagram and annotate it, right? It's a reimagining of trust boundaries. And the hypothesis was that we could generate 80% of the relevant threats for the price of an accurate DFD. And if you think back, we said that's something we thought they were pretty good at. And that would leave software engineers free to think about like the remaining 20% of harder stuff. Instead of drawing a box to encapsulate every entity, like you score it. So you score each entity. If something's on the open internet, it's a 0. And you can go look this up. You don't have to learn it here. Don't worry about trying to learn it here. If it's on the edge, it's a 1. And if it's a data sink, it's a 9. The numbers 2 through 8 in between just sort of increase as you move toward the sink. And so once the diagram is labeled, we can apply rules. So here for elevation of privilege, we can say anytime the destination, select any destination where the source zone is less than the destination. So something from low privilege is sending data into high privilege. Spoofing. Anytime something is originating from the internet and hitting something on the edge. So you can just see this as an encapsulation of STRIDE rules and good best practices about when to identify which STRIDE threats. You got a rule for tampering, you got a rule for repudiation, denial of service, so on and so forth. It's easy for software engineers actually to annotate a diagram that they drew and draw the same diagram and the same annotation each time. And so this gave us a way to have, we'll call it deterministic threat modeling. It was a significant improvement for us. And that led us to the next piece. We knew we wanted these to be test cases. We knew we used Gherkin. It provided structure. You could parse it. And what would be cool is if one day, like, people adopted test frameworks like Gherkin, we could just wire it to test automation. But that miracle never came. Nobody cares about Gherkin. I still say it wasn't all bad. It was important for other reasons. So with all these pieces, we had a way to create these Gherkin formulas. For example, because data flows from entity X to Y, you have threat Z. This made it easier for developers to understand, like, why is the threat existing, something like traceability. It allowed them to really focus on mitigations to complete the formula rather than identifying the threat. And these pairs, again, going back to what we said, were the test cases that they were tasked with making. This was machine readable, it was structured, and it was saved forever. And since software engineers were checking all this in and running these rules by hand, then automating these rules was the lowest hanging fruit. So we learned everything about parsing, for example, the draw IO diagrams they were already giving us. And we sort of realized we could model this problem as a property graph where the nodes and edges of the DFD are the entities, or rather the nodes. Anyway, the nodes are nodes and the edges are edges, and it maps nicely to a property graph because that's what it's got in it. But if you want to say data store or process or entity, you store those as properties, as you can see here. So you can actually store this in Neo4j. That's like the natural place people encounter property graphs, but you can also store this in a regular relational database using this strategy over here, just tables of nodes and edges. So that meant that what that meant was we could treat the diagram as a data ingestion, like I ingest the diagram and then I run SQL to query the diagram for the RTMP rules. I don't do threat modeling of stuff, I query data to run an analysis. And actually this is still done today. So I implemented this. There's a project out there called Materialized Threats. I'm not able to show you the actual developer portal from the inside of my previous employer, so I'm not going to do that. But if you want to check out how a tool like this works, you can check out Materialized Threats. It's on GitHub. But what we had was risk assessment and threat modeling. You logged in, we knew who you were, we knew what teams you work on. We showed you the relevant stuff. If you needed a threat model, you did it in our tool, and out came 80% of the test plan. And that was all committed to Git and ingested into Snowflake for analytics and research. So that took us kind of to our run phase. So finding more velocity for teams was a big motivator for us. But despite everything we built, all that cool stuff, we were still drowning from consulting and peer reviewing everything because the engineering work kept growing. Like, we kept inventing more stuff and hiring more people to do it. And we had to get real with ourselves about why we had to be involved in every security review at that point. So we had to invent a way to trust software engineers. What would it take for us to do that? We had to reimagine what our role would be. Right? We wanted to arm and train this local population and go back into the jungle, right? Develop the next generation of capabilities based on their feedback. We thought we had done a pretty good job of that with risk assessment and threat modeling in this developer portal, and we wanted to do a lot more of that. So putting it all together resulted in what we affectionately called the golden triangle. This is not golden. The overall premise for teams is that low risk is a fast ship. If your risk is not low, it's as good as saying, we need to create security requirements specific to this design, and threat models is how we're going to do that. So that currency you're generating is those security requirements that mitigate current and, most importantly, future risk. So we kind of is saying, again, every threat model is a failure by the risk assessment to prevent it, and a failure to have identified the security requirements a priori that would have mitigated the risk. Finally, we knew we couldn't just hope for good intent. We had to plan for the worst. So we had autonomy levels. We had a way to measure your quality, and we would take your autonomy away if you were bad, and we would give it back to you if you were good. And taking autonomy away meant blocking security reviews. We used a random sampling strategy to do these quality assurance audits. So, we had 1,000+ software engineers risk assessing every change, doing stride when they needed to. It was a standard, repeatable process, peer-reviewed, collected data. Pretty good, right? Pretty good. But that dream really gave way to my next argument, which is we were just, things that we thought would create developer value, like a little bit of a delusion. We were really just minimizing tax, which is, again, not the worst thing, but we were minimizing tax brought on by security review. And security review was still an additional activity that they had to go and do. And as we added more developers, those activities and that whole system started to show cracks. We call it maybe death by taxes. So I'll highlight some key areas where it broke down for us. I emphasized a lot on how important it was to capture that threat modeling data. Boy, did teams not do that. Many teams did not update their risk assessments at all. Like that was a tax. So they never updated it with what they learned from their threat models. These teams had the worst feedback when they were surveyed. They had the highest number of high-risk reviews. They had the highest number of QA issues. They were just threat modeling the same things over and over and over, and they hated that, and they told us that. But what was funny and interesting was it was really hard for them to get unstuck. Even if we have really good dedicated security partners in those teams, we still struggled to get them unstuck. And so one of my realizations was you just can't count on everybody seeing the light. Like some people are never going to see the light, and you need to be resilient to those things. And the second thing we realized was that we did not invest quickly enough in roles and programs dedicated to creating and maintaining culture with developers. Like that's not a side project. And you're going to see that this presentation is very technology heavy. I think if there's one thing that we needed to do differently, and I would do differently in the future, is much more emphasis on the culture standing next to the technology as something you have to really heavily invest in. It's not a side project. Well, okay. I'm not sure what happened there, but let me just get this back where I was. Just a second. Exciting. Okay. Here we go. Okay, we're back. And there we go. All right, cool. Thank you for that. So, challenges. Most teams updated their risk assessment only once. Some of them updated semi-regularly. They had the best feedback when surveyed. Some teams had no interest in being autonomous at all. That was the most surprising plot twist. They wanted us to be involved in everything they did, and we did that for the people who really wanted it. Okay, so quality control. An early fear we had was that we made this threat modeling too easy, and we did. In some sense, if you could get 80% of it for free, like how many people might just leave it at that? It's not zero. We weren't surprised, but we were surprised how costly it was for us to detect that and remediate it. And so our quality control load grew linearly with the number of software engineers that ran the process. That improved with really high-touch training, more work, but it decayed with growth and required continuous investment. So just sort of going back to what I said, we were not making enough of that investment. So code reviews often involve like seemingly trivial things that are easy to misunderstand, and engineering teams usually get better at this. But risk assessment and the threat modeling really don't improve over time. And that's because security language is fundamentally foreign. You don't always gain proficiency. And so all of the software engineering energy is kind of consumed with this translation thing. And they don't always have time to think about what the future improvement might be. So we teach them to speak security like children, but we ask them to think about it like an adult. And often we're asking them to think about adult problems. And many times developers are deciding like shipping is more important than figuring out why they're not getting relevant security advice. So whatever we think developer friendly is, it's not. It's developer taxes. It's the unmerged PRs. It's the unpatched VMs. It's the failed QA deliverables. It's the diagrams they never used because they just didn't care about these things. It was just security tax and activity that they had to do and could not get out of. And what we were doing was trying to build a bridge. And I think that bridge building in general is a problem. So we thought we were living a dream. We needed some new dreams. I'm going to speed up a little bit here, and that's going to happen again. That's exciting. In just a second. We had to come up with we had to take sort of the existing ideas that we had, and we had to come up with some new ideas. And the existing ideas that we had were sort of the things I've talked about so far, where every consult's a failure, every threat model is a failure. I think something really important is if you're not sort of ruthlessly trying to eliminate threat models by capturing and curating security requirements and then using that data to create secure defaults, then you're just kind of producing low quality stuff. A massive challenge that we faced was not being able to ship secure defaults into development until much later. And that forced us to really focus on a secure design approach, which was a losing battle as complexity went up. So some new ideas were just that, look, we have to recalibrate what we expect. If we have to depend heavily on partners, we're doing it wrong. It doesn't mean I know what the answer is, but I know that as long as we have to depend on partners, we're doing it wrong. Another important thing is to think about killing security review as an idea. We think that today the state of the art is CI integration, PR integration. I don't think that's going far enough. Engineering design involves Jira's, Slack conversations, Confluence pages, Google Docs. Software-driven risk assessment and threat modeling really should be a conversation with these design docs and work definitions that are already being created. And we should be thinking about data ingestion and information extraction as a fundamental means to understanding and modeling these systems for security review. We shouldn't be expecting software engineers to explain things over and over to us. We should be understanding their documents, conversing with them to confirm our understanding, and then improving that documentation alongside the developer. So with this mindset shift, we don't have tools. We have questions we want answered. And this extends to everything. It's not about visiting a bunch of tools. It's about ingesting, modeling, and presenting data in a consistent way. By doing this, we can make sure that we always deliver the alerts in the context that we want. We don't have to bend to what the tool wants. We can deliver this in a document, in a Slack conversation, in a Jira, whatever. It also allows us to have a vendor agnostic view of the world. So here we're talking about data, and I'm going a little bit fast because I'm a little bit pressed for time due to my errors, but that's okay. We're going to get now into what are we using this data for? We talked a lot about how we got it all in there. So first, most obvious thing, risk assessment. What team are you on? You use Workday data to figure that out. What were the technologies you used? Who was the security partner involved? And what were the specific risk assessment, or rather security requirements for you? That was all stored in Snowflake tables, queried at runtime. Since security reviews were first-class things, we could understand which projects included them and met them, and we could calculate residual risk for them. By knowing the starting and ending risk, we could look back and see where we had potential risk that was mitigated and actual risk that was unmitigated across our system. It also made us easy to see where requirements were not met, which made quality control much more straightforward. You've already seen that we were powering Stride with SQL, and you've already seen that we were generating the gherkins from those strides. So we were able to do that and just answer this question of what is the test scenario. But something that we didn't really foresee that was extremely powerful to us was if you work in a place with a highly complex and poorly documented system, you may struggle to understand what is this. And what we were getting was a crowdsourced model of the system. And we could understand what were all of the nodes and edges. We could understand where new nodes and edges had been introduced. We could understand all of the paths to reach different nodes and edges and whether or not those paths were possible. Because we had all this high fidelity information, we could go back and solve more problems. For example, we could easily normalize all of the names of entities with technology, I would say LLMs or language models in general, or document AI models. And so something we went through was to go and normalize all of the entity names and use it to enrich our asset inventory data. Something else we did was use the data in not language models, but just use predictive models in general to autocomplete gherkins. Given the gherkin input, the system you're working on, and the generated boilerplate, what is the most likely completion for that? We could also do things like auto-completing the diagram. If you drew part of the diagram, we could guess based on which nodes and edges you had, which ones you might be missing. We could suggest the diagram from the data flow diagram. We could detect whenever you drew a threat model that conflicted with another threat model. And I think sort of my closing point here, and where I think a lot of this starts to bleed over, is once we have all of this structured data deterministically about what's going on, where LLMs, I think, really provide value, the field of NLP has moved forward quite a bit, is to eliminate this translation tax. We're constantly cycling between developers understanding and security engineers understanding, thousands of hours. And I think that what we can do is put an end to this suffering and transform the way we talk about, rather, what we understand and the way that we communicate it by, for example, reading documents, suggesting the diagram, confirming our understanding of that diagram, and then storing that model in a shared system that security engineers are also viewing. So what we have is the same model existing in both people's heads, rather than two people trying to synthesize two different models. Another thing to think about is this whole feedback loop, which is with all of the structured data and all the analysis we can do, and by feeding this back into the developer artifacts, you begin to scratch the surface of what providing value to a developer could look like. The value in this scenario is I'm helping you confirm the accuracy of your doc. I'm helping you complete a task. Those are technically taxes, but I think improving your document by virtue of this process is a potential value add. And one thing I want to highlight kind of in closing is that we're talking about, not talking that heavily about LLMs. I think there's a sweet spot where they work in mapping terms. I think reasoning with LLMs about security is dangerous and doesn't make scientific sense to me. But I do think where there's a ton of value is to stop the translation tax of painful security terms trying to be mapped to engineering terms. Maybe one final idea that we had was by having this model of the system, you can express arbitrary constraints. You can express constraints that extend to any of this data you can model. So don't design a doc this way. Don't write it that way. In addition to don't write your code that way or don't deploy your asset that way. So these are the ideas of where I think the future is. I think engineering eats security in the end. And thanks for coming to my talk.
Thank you so much, Jacob. I think the last image probably doesn't generate the nightmares for me for this night, but the risk assessments, I think at one point coming to engineers wanting quick security reviews, it might be a bit scary. I think it was on one of your slides. I think we don't really have time for the questions. So we unfortunately will a bit over time, and we have just 2 minutes buffer between the next talk. But for everyone, feel free if you want maybe to give your LinkedIn link. So if people have some questions, they can reach out to you directly.
For sure.
And ask you a bit more about this topic and share their problems. I'll just can connect with Jacob on LinkedIn. You can find the link in the chat. So every talk is just a reminder for everyone, every talk is recorded, so you can access it once the event ends, and we'll publish the recordings eventually on the Elephant and AppSec YouTube channel.
Thank you very much.
Thank you so much, Jacob, and have a great day.